Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering a whole new topic called Cross-Origin Resource Sharing, or in short, CORS. Just like with the other theory videos, this is pretty much a brain dump of everything that I know about CORS attacks, and so it's going to be a long one. But by the end of the video, you'll have all the fundamental knowledge that is required to complete the 4 hands-on lab exercises that we'll be covering in the next upcoming videos. Alright, let's get started. The agenda for today is to first cover the technical details behind CORS attacks. So what is a CORS vulnerability or a CORS security misconfiguration? What are the different types of CORS vulnerabilities? How common are CORS vulnerabilities? And so on. Next, we'll cover how to find CORS vulnerabilities from both a white box and a black box perspective. So if you're given an application and possibly even the application source code, how would you approach testing the application in order to determine that it's vulnerable? Once you've found that the application is vulnerable, how do you exploit it in order to achieve your end goal? And then we'll end the presentation by covering the different techniques that you can use in order to prevent or mitigate CORS attacks. Okay, let's get started with the first section, which is what is a CORS vulnerability or a CORS security misconfiguration. Now, before we discuss that, we need a bit of fundamental knowledge about how different web applications interact with each other. And the first concept we're going to learn about is the same origin policy, or in short, SOP. The same origin policy is a security mechanism that is enforced by browsers to control data between web applications. So if you've got a banking application and a shopping application, by default, the interaction between these two applications is limited. The banking application is able to make requests to the shopping application, such as, for example, submitting a form. However, it cannot read the response from the application. And this is not something that you have to configure on the web server. It's something that is implemented by default in all browsers. So if you try to read data from another application, let's say youtube.com, it will also be denied by default by the browser. Now you might be wondering why this policy is built into browsers, and the reason is really simple. It's done for security purposes. Imagine you're a user that is visiting this shopping application for the first time and you have no idea that it's actually malicious. And when I say malicious, I mean that the shopping application contains a script that automatically makes a request to your banking application, which you're logged into from the same browser, and asks for your banking info, such as the account number or your balance or your personal information. Now, if there's no such thing as a same origin policy, your banking website will gladly hand over that information on a silver platter. And that's why it's really important to have a control such as the same origin policy, because if it wasn't there, all the applications can pretty much attack each other and access each other's data. And so to prevent that, all the browsers have this policy built in. Now, there's a really important distinction that you need to understand with the same origin policy, and that it does not prevent writing between web applications, it prevents reading between web applications. So in our example where the shopping application was malicious, it's still able to make a request to the banking application requesting your banking info. However, when the browser sees that request, it'll check the origin of the request. So it'll check where the request originated from. And in this case, it originated from the domain, let's say shoppingapplication.com. And that domain is different from the domain of the banking application's website, which is, let's say, bank.com. And so what the browser is going to do, it's going to reject that request because those two applications have different origins. So 2 important things to understand about the same origin policy. The first one is that it does not prevent writing between applications. What it does is it prevents reading between web applications. And the second one is that access is determined based on the origin. And that's at a high level overview how the same origin policy works. Now let's get into the nitty-gritty details because this will come in handy when discussing the next concepts that we need to learn about in the video. So we said the way that the same origin policy works is it checks the origin of the request when it receives it, and if it's different from the origin of the website where the request came from, then it rejects the request. Now we've so far defined the origin as the location where the request originated from, but what does that really mean? Well, two URLs are defined to have the same origin if the protocol or the scheme, the host name or the domain, and the port are the same for both. So for example, if my website, renakhalil.com, running on port 443, is making a request, the origin of my website is made up of the scheme or the protocol, which is HTTPS, the domain, which is renakhalil.com, and the port, if it's specified, which in this case it is, so it's port 443. Now, if the port is not specified, it'll default on the port that the scheme is using. So if the scheme is HTTPS, then the port would be 443, and if it's HTTP, then the port would be 80. Now, the combination of the scheme, the host, and the port makes up the origin of the request. So let's take a few examples to see if we properly understand this. Imagine you've got my website, http://renakhalil.com/courses, and it's trying to make a request to the following websites in this table. What we're going to do is we're going to evaluate each scenario in this table to see if the same origin policy will allow the request to extract data from any of these sites. And we'll start off with the first one, which is my site over here making a request to the site http://renakhalil.com. So in this scenario, it's the same domain, it's just making a request to a parent directory of the site. Now, is this allowed by the same origin policy? Well, let's apply our methodology. Does it have the same origin? In order to determine that, we need to check the scheme, the domain, and the protocol. In this case, the scheme is HTTP for both of them. The domain is also the same, it's renakhalil.com, and the port is also the same, so it's not specified, which means it defaults on the port that the protocol is using, which is port 80. And in both cases, they're using the HTTP protocol, and so they're both using port 80. Therefore, yes, this read request will go through because they essentially have the same origin, so they have the same scheme, the same domain, and the same port. All right, let's take another example. So imagine my site over here is making a request to the site http://renakhalil.com/signin. So it's making a request to the same site. However, it's making the request to a different page or a different directory in the site. Now, will this be allowed by the same origin policy? Well, let's apply our methodology. So we've got the protocol, it's the same, the domain, renakhalil.com, it's the same, and the port is port 80, it's the same for both of them, and therefore, yes, it's permitted by the same origin policy because it's got the same scheme, the same domain, and the same port. So it doesn't matter if you're in a different directory because that's not what is used when you're determining what an origin is, and so this is allowed. Let's move on to the next example. So imagine my site is making a request to the site https://renakhalil.com. Will this be allowed by the same origin policy? Again, let's use the methodology we learned about. We start off with looking at the scheme or the protocol. In this scenario, it's using HTTPS, whereas my site is using HTTP. The domain is the same. The port is different because HTTPS uses port 443, whereas my site is using HTTP, which uses port 80. And therefore, no, the request will not go through because it violates the same origin policy since the origins are different. And when I say different, it's because they have a different scheme and a different port. And so the request won't go through. Okay, let's move on to the next example. So imagine my site over here is making a request to the site http://academy.renakhalil.com. Now, is this permitted by the same origin policy? The answer is no, because although they use the same protocol and the same port, the domain is different. In this case, it's renakhalil.com, whereas in this case, it's counted as academy.renakhalil.com. So it doesn't matter that it's a subdomain of the parent domain, it's still counted as a different domain, and therefore the same origin policy will not allow it to go through. Okay, last example. Imagine my site over here is making a request to the site http://renakhalil.com running on port 8080. Now, will this be allowed by the same origin policy? The answer is no, because although they're using the same scheme, the same domain, it's still a different port. This one uses port 8080, whereas this one uses port 80, and therefore the origin is different. Okay, so we've gone through a couple of examples to see how the same origin policy works. Now let's discuss what happens when an origin makes a read request to a different origin. So essentially what happens when the same origin policy is violated and the browser prevents the request from going through. So this is a screenshot of me trying to make a read request from my website ranakhalil.com to google.com, and as you can see, my request is denied because it violates the same origin policy. And the error it gives me is access to google.com from the origin ranakhalil.com has been blocked by something called a CORS policy. So that's the next concept we're going to learn about today. Cross-origin resource sharing, or in short CORS, is a mechanism that allows resources on a server to be requested from another domain. So in some cases, you might want to loosen up the grip of the same origin policy and allow cross-origin interaction. We see that quite often with modern web applications. Many websites either need to interact with their subdomains or third-party sites. And in this case, you don't want the same origin policy to stop that interaction. And so what these websites do is they make use of the cross-origin resource sharing protocol. And as usual, to understand this, let's take an example. Imagine you have two domains, domain A and domain B. Domain A is a shopping application and domain B is an analytics application. Now, domain A has a legitimate use case to access the resources of domain B. And so in order for that to happen, domain B would have to configure CORS rules in its web application. And the reason it needs to do that is because of the same origin policy. You could see over here the same origin policy compares origins, right? And we said an origin is made up of the protocol, the domain, and the port. So if these two sites are using HTTPS, there's still a different origin because the domain of the site is different. This one is using domain A.com, whereas this one is using domain B.com, and therefore the same origin policy will prevent that request from going through. However, there's a legitimate use case for that request to be made, and so what ends up happening is that the developers configure CORS rules on the web application in domain B.com, telling it if there's a request coming specifically from domain A.com, then allow that request to go through. So in this case over here, domain A is able to interact with domain B because domain B makes use of the CORS protocol to allow domain A to access it. Now, how is this access configured? Well, that depends on the languages, technologies, or frameworks that you're using. So for example, if you're using the Spring framework, it's as simple as using annotations, and the configuration can be either fine-grained or global depending on the use case that you have for your application. I'm not going to go through a detailed explanation of how you configure CORS rules because it might not apply to you. Some of you might be using Java, whereas others might be using Python, whereas others might be using PHP. And it's slightly different depending on the language or technology that you're using. So instead, what we're going to focus on is how the server and the browser behave once CORS rules are configured. And to properly understand that, we're going to go back to the definition of CORS. So we said that cross-origin resource sharing is a mechanism that uses HTTP headers, and that's an important one. So it uses HTTP headers to define the origins that are allowed to access your site. So essentially, once you configure CORS rules in the backend, the way it's able to communicate that to the browser is through the use of HTTP headers. And there's two HTTP headers that you will come across when performing cross-origin requests. The first one is the access control allow origin header, and the second one is the access control allow credentials header. And we'll go into more details on each header in the next few slides, starting with the access control allow origin header. The access control allow origin response header identifies to the browser if an origin is permitted to access the resources of a specific website. So let's take an example to properly understand that. Again, we've got our applications, domain A.com and domain B.com. It's a shopping application and an analytics application. The shopping application needs to be able to read data from the analytics application, so it sends a request to the homepage of the analytics application. The request will look something like this, where the origin is domain A.com because that's where the request is coming from. The host is domain B.com because that's where you want to extract data from. And you're requesting the home.aspx page. Now, if domain B has CORS rules configured where it says if you get a request from domain A.com, then allow domain A to read the response of the request, you'll see a response that looks like this. And it makes use of the access control allow origin header in order to indicate to the browser that the application is able to read that request. So the access control allow origin header would have the origin of domain A.com. So in this case, it's domain A.com. And when the browser sees that, it'll allow the response to go through and be presented to domain A.com. Now, if there are no CORS rules configured at domain B.com that say specifically allow domain A.com to access my resources, this header would not be present, or this header would have a different domain in it. And when the browser sees that, it sees that the origins are different and it will prevent the response from reaching domain A.com. And that's essentially how the access control allow origin header works. Now there are rules on how you could use that header. So you've got 3 options in the way you configure it. The first one is using the wildcard character star. And what that essentially says is that any site on the internet is allowed to access my resources. And that has its own security implications, and we'll talk about that in the next section. Now, the next option for configuring the access control allow origin header is to allow a single origin to access your site. So in the example we saw in the last slide, we allowed domain A to access the resources of domain B.com. And so in this case, we specified the origin that is allowed to access our resources. Now, it's important to note over here that this only allows you to whitelist a single origin and not multiple origins. So it's not like you could add an origin over here and then add a comment and add another origin and then add a comment and add another origin and so on. And so this contributes to the issues of, people trying to get around that. And this contributes to why there are so many security issues, because most sites need to trust multiple domains. However, that's not an option. It's either you whitelist all the hosts on the internet or you whitelist a single domain. Now there's of course a third option, which is the null option. So some applications might want to whitelist the null origin for several reasons, and that includes cross-origin redirects and sandboxed cross-origin requests. So that's an option as well. Of course, that comes with its own security issues, and we'll talk more about that in the upcoming slides. Okay, so that's the syntax for the access control allow origin header. Now it's important to understand that the access control allow origin header allows you to only access public pages in the application. In order to access authenticated pages, you need to use another header called the access control allow credentials header. So the access control allow credentials response header allows credentials such as cookies or authorization headers or TLS client certificates to be included in cross-origin requests. And again, to properly understand that, let's take an example. So imagine you've got our same applications, domain A and domain B. Domain A needs to access an authenticated page in domain B. So let's say it's account details page, which only authenticated users can access. So in order for domain A to be able to access domain B, both headers need to be configured in the domain B application. So you've got the access control allow origin header that says domain A is allowed to access my resources, but you've also got the access control allow credentials header set to true, which says that you're allowed to pass credentials in the request. And therefore, domain A is able to access authenticated resources from domain B. So the syntax for the access control allow credentials header is really simple. It's either set to true, which means that you're allowed to pass credentials in the request, or it's not set at all, which means that you're not allowed to pass credentials in the request. Now, it's important to note that there are restrictions on when you can use that header. So if the access control allow origin header is set to the wildcard character, which is the star character, then it's no longer allowed to set the access control allow credentials header to true. And the reason is for security purposes. So if you've got the access control allow origin header set to star, that means any origin on the internet is allowed to access your website. And if the specification had allowed this type of configuration to be set with the access control allow credentials header to be set to true, that means not only can any origin or domain on the internet access your resources, it can also access your authenticated resources. And this causes a huge problem. This is why the specification does not allow you to pass credentials when the access control allow origin header is set to the wildcard character. Alright, so we talked about the theory behind CORS attacks. Now let's talk about a scenario where CORS vulnerabilities are introduced. Imagine, again, you've got a banking application and you've got a user that accesses that banking application. So the user logs into the banking application and stays logged into the banking application in one of the tabs on his browser. The next thing the user does is he Googles cat images and ends up landing on this site over here, catpics.com. Now the user is just looking at cat images because they're cute. However, he has no idea that this site is malicious. So what the site does in the background while the user is looking at cat images is it requests the resources of the banking website. And since the banking website has CORS rules that are misconfigured in a way that introduce security risks, what the banking website is going to do is it's going to allow the malicious website to access the resources of the banking website. So in this case, it requested account details, and so it requested the account details of the user. And you could see over here in the misconfiguration was that it had configured the access control allow origin to allow catpics.com. And you might be wondering, well, did the banking website even know that catpics.com even existed? Why would it allow it to access its resources? And that'll become clear in the next couple of slides when we talk about how CORS rules are configured. And you could see allow credentials header is set to true. And so therefore, when catpics.com made that request in the same browser where the user was logged in, the browser looked at the request. It saw that the application is accepting requests from catpics.com, and it also allows for credentials to be passed through. And so the user's cookie got passed through, and it requested the resources and it presented them to the catpics.com page, giving the attacker access to your banking information. Now, the real question is, why was this website vulnerable to CORS attacks? And to properly understand that, we need to talk about why CORS vulnerabilities arise in the first place. And the first thing to understand is that CORS vulnerabilities are essentially just configuration issues. That's why you might have caught me a couple of times in the video refer to CORS vulnerabilities as CORS misconfigurations or CORS security misconfigurations. And that's because it's essentially just a misconfiguration on the developer's part that caused a security risk. However, it's important to note that the standard that defines the restrictions on how CORS headers are allowed to be set makes it a bit too easy for developers to make mistakes when it comes to configuring CORS rules. And that'll become clear in a second. So if you remember, a few slides ago, we talked about the different options that are allowed to be set on the access control allow origin header. And the options were 3. The first one was the wildcard character, which allows all the different origins on the internet to access your site. The second one was the ability to whitelist a single origin. Again, remember for this option, it only allows you to whitelist a single origin. It does not allow you to whitelist multiple origins. And the third option was the null option. So there is no possibility for the access control allow origin header to contain multiple domains. Can anyone guess why this might be an issue? Well, in a real-world scenario, the architecture of how applications communicate with each other is complex. Applications need to be able to trust multiple domains in order to function properly, just like our example of the shopping application. Maybe it needs to trust an external payment provider, or maybe it needs to trust an analytics software or even a subdomain. However, the standard does not give you an easy way of whitelisting multiple origins. The only option you have is you either whitelist a single origin or all the origins by using the wildcard character. And obviously, you don't want to whitelist all the domains, so you need to find a way to get past these rules and only whitelist a select number of domains that you actually trust. And that's where dynamic generation comes to play. So if you want to trust multiple origins, you're left with dynamically inspecting the origin header from the request and deciding if you trust it. Now, if you trust it, you reflect it back to the user. The portion in that process that introduces the security vulnerabilities or the security risks is the logic of the code that decides how you can determine if an origin is trusted by your application. And across time, we've seen many different insecure implementations of that functionality. We'll see a subset of the most common ones in this slide over here, starting with the first one, which is simply extracting the origin header from client-side input and reflecting it back to the user. So if we take my website, ranakhalil.com, as an example, and my site is making a request to the shopping application's website, what ends up happening is that when the shopping application sees my request, all it does is it extracts the origin of my request, which is ranakhalil.com, and then it inserts it in the access control allow origin header, thereby allowing my application to access its resources. Now, this is equivalent to you using the wildcard character because it essentially will allow any origin that accesses it to access its resources. All it's doing is extracting the origin and then reflecting it back to the user. So there are obvious security issues with that because you're allowing all the origins on the internet to access your public resources. Another example that we've seen is accidentally introducing errors in the way that the application parses the origin header. So when trying to implement this functionality, some applications parse the origin header from the request and then try to match it based on either the URL prefixes or suffixes or using regular expressions in order to determine if it trusts that domain. Any incorrect implementation in that regular expression causes security issues. An example is granting access to all domains that end in a specific string. So this site over here, bank.com, would like to trust all its subdomains. And so the developers thought the way that they would do that is they would use dynamic generation by inspecting the request when it comes through and then comparing it to a regex that only grants access to domains that end with the specific string bank.com. However, this is an incorrect implementation because it has security flaws. And an example bypass of that is me as an attacker. All I would have to do is register a domain and make sure that that domain ends with that specific string. So in this case, I register the domain maliciousbank.com, and that domain will bypass the regex rules that exist in the banking application. Another example is granting access to all domains that begin with a specific string. Again, assume that the application only grants access to domains that begin with the string bank.com. A way to bypass that is to simply use your malicious domain and create subdomains that match that specific string that the application is checking on. So in this scenario over here, I've created a subdomain bank.com on my malicious website that is malicious.com in order to bypass that regular expression. So it really depends on how the developer decided to implement the logic of the application that makes the decision on whether the origin is trusted or not. And the last example is whitelisting the null origin value. Again, this is equivalent to using the wildcard character because if I tweak my malicious script and make it run my request in a sandboxed iframe, it'll appear as if it's coming from the origin null and therefore it will be allowed to access the resources of that site. And we'll see an example of that in the upcoming section when we talk about how to exploit CORS vulnerabilities. Now, to make things worse, I think the null header is even worse than the wildcard character, so the star character, because it doesn't abide by the same rules that the wildcard character abides by. So if you remember a few slides ago, we said that you can't pass credentials when you're using the wildcard character in the access control allow origin header. That was because this way, all the applications on the internet would be able to access not only your public resources, but also your authenticated resources, because your credentials, whether they're cookies or authorization headers or TLS certificates, will get passed in the request. However, the null origin does not abide by those rules. You're allowed to send credentials using the null header, and effectively, if you decide to whitelist the null header, any application on the internet can make its request appear as if it's coming from the null origin. And so that makes it much worse than the wildcard character. So these are just a few examples of how to exploit CORS vulnerabilities. There might be other examples out there. It really just depends on the logic put in place in the function that decides if an origin is trusted or not. Alright, so far we've talked about what CORS vulnerabilities are, and we looked at a few examples that we see in the wild. Now, let's talk about the impact of CORS vulnerabilities. The impact really depends on how the application is configured. So if you're allowing credentials to be passed across requests and have insecure controls on the origins that are allowed to access your site, then you're at a much more risk than if the credentials header is not set to true. So it really depends on your application. I've seen several scenarios where CORS vulnerabilities would only allow you to extract sensitive information. However, I've also seen scenarios where CORS vulnerabilities will allow you to gain remote code execution. And so in this case, confidentiality, integrity, and availability would all be high. So it really depends on the context that you're running with and how the application is configured. Now, there's a really good article that is written by James Kettle. The title of the article is Exploiting CORS Misconfigurations for Bitcoins and Bounties, and he goes through a variety of examples explaining how to exploit CORS misconfigurations, and it goes through examples where the impact is only being able to extract sensitive information, all the way to examples where the impact is remote code execution. So I really recommend reading this article if you get the time. Another article I would recommend is written by Barak Tawili, if I'm saying that correctly, and it explains the exploit for CVE 2019-9580, and that's essentially a CVE where the security researcher was able to gain remote code execution because of a CORS misconfiguration that trusted the null origin. And so this is definitely an article I would recommend reading. All right. We talked about the impact of CORS vulnerabilities. Now the question is, how common and how critical are CORS vulnerabilities? And one way to measure that, and it's not bulletproof, is the OWASP Top 10 list. So for those of you that have not heard of the OWASP Top 10 project, it's essentially the list of the top 10 most critical security risks in web applications today. It's updated every couple of years, so you could see on the slides, we've got the list from 2013, and then the list from 2017, and then again the list from 2021, which only came out a few months ago. Now, CORS misconfigurations do not appear by name in the list. However, they do fall under the security misconfiguration category, which is the 5th most critical security risk to web applications today. Now, of course, this does not only include CORS vulnerabilities, it includes all the security misconfigurations that could affect web applications and their components, and so we can't really use that to measure if CORS attacks are really the 5th most critical security risk to web applications today. However, we have seen them on the rise in the past decade or so with the use of APIs, and so it's definitely something to check out for when you're testing applications that make use of the CORS protocol. Alright, in the past couple of slides, we discussed what CORS vulnerabilities are, the different types of CORS vulnerabilities, the impact of CORS vulnerabilities, and how common and critical CORS vulnerabilities can be. In this section, we'll discuss how to find CORS vulnerabilities. So imagine you've been given an application and asked to test it. How would you go about testing this application to see if it's vulnerable? Okay, before we cover that, it's worth mentioning that the methodology used for finding CORS vulnerabilities differs from one person to another person, and it's usually developed by experience. So just because I give you my own methodology doesn't mean that you have to follow it to the letter. Instead, I would recommend that you take what is useful for you from it and then build and add on your own methodology as you gain more and more experience in web app pen testing. And like I say in all my theory videos, this statement applies to finding all vulnerabilities, not just CORS vulnerabilities. Okay, so I've decided to split this into 2 categories depending on the perspective of testing, and the 2 categories are black box testing and white box testing. For those of you that have never heard of these terms before, black box web application pen testing is when the tester is given little to no information about the system. Usually, the only information that the tester has access to is the URL of the application and the scope of the engagement. Whereas for white box web application pen testing, it's the complete opposite. The tester would be given complete access to the system, including access to the source code of the application. Now, there's a third category that I haven't included on the slide, and it's called gray box web application pen testing. This is a combination of both white box and black box pen testing, where the tester is given limited information and access to the system. So for example, instead of just giving the tester a URL to the application, the tester is also given accounts to the application. Now, when it comes to my methodology of finding CORS vulnerabilities, I loop both gray box and black box pen testing into one category, and that's because my methodology is the same regardless of that perspective of testing. If I'm approaching it from a black box perspective, my scope will be much more limited than the gray box perspective unless I find an authentication bypass vulnerability. Nevertheless, the methodology for testing for these types of vulnerabilities in public or authenticated pages is the same. However, when it comes to white box pen testing, you're actually given the code of the application, and so there's an element of code review, and that's why I put it in a separate category. Alright, let's start off by talking about how to test applications from a black box perspective. The first thing that I do when testing an application is map the application. And what that means is I literally visit the URL of the application and walk through all the pages that are accessible to me within the user context that I'm running as. And while I walk through all the pages in the application, I try to see if there are any CORS headers that are used by the application. Now, if there aren't any CORS headers that are being used by the application, that doesn't mean that the application does not make use of the CORS protocol, because it's possible that the application makes use of dynamic generation, and that only comes into play when you have an origin header that needs to be dynamically generated in the backend. And so I start testing for dynamic generation. And in order to do that, you have to apply all the rules that we learned about. So like I said, some applications simply extract the origin of the request and then reflect it back to the user. So a way to test for that is to simply intercept your request in burp, send it to repeater, and then change the origin header to a random value and see if it's reflected back to you. If it's reflected back to you, that means the logic in the backend application, all it's doing is literally extracting the value in the origin header and reflecting it back in the access control allow origin header. Now, some applications make use of more complex logic, like the use of regex expressions, and so you're going to try to figure out what that regex expression is and if it's exploitable. So a way to do that is for applications that only validate the start of a specific string. Usually the start string would be the domain of the application. So you would add the domain of the application, and then you would add your own malicious domain after that in the origin header and see if the application accepts it. Similarly, some applications only accept a specific string in the end. Again, the way to exploit that is to add a few letters to the beginning of the string and see if it accepts it. If it does, that means you could register a malicious domain that has the same ending as the domain of the application that you're testing. However, it's under a completely different domain that is under your control. And so this is a way to test for that type of insecure regex implementation. Another thing to test for is the null origin. Again, we said that the null origin is technically more insecure than the wildcard character. So just add null to the origin header and see if the application accepts it. If it accepts it, then it has the null origin whitelisted. If it doesn't accept it, then it doesn't have it whitelisted. Next, you could see if it restricts the protocol. So try the same domain of the application, but instead of using HTTPS, just use HTTP. And if that's allowed, maybe you could combine it with other attacks in order to prove your impact. Another thing to look out for is, does the application allow the passing of credentials? And this is a really important one, because if you've got only the access control allow origin header that is misconfigured, there's only so much you could do with that. However, if the access control allow credentials header is set to true, then your vulnerability is more likely to rate at a higher CVSS rating because it has much more impact if the credentials can be passed. This way, not only can you access public pages, but you could also access authenticated pages. Now, once you've determined that there is a CORS vulnerability, you need to review the application's functionality to determine how you can prove impact. So sometimes when you're submitting these reports, some people don't understand what the impact of that is. And so sometimes you need to combine it either with another vulnerability in the application, or you need to combine it with a functionality in the application. So if the application, let's say, stores API keys in the user interface, what you could do is you could use the access control allow origin header in order to extract that API key and then gain access to the application. And this way, you've completely took over the entire application, and therefore people will take your report much more seriously. In the next section, we'll talk about how to exploit CORS vulnerabilities and how to develop scripts that will present as a proof of concept that this CORS vulnerability is exploitable. Okay, the next perspective of testing is white box testing. So this is not my preferred way of testing. I usually prefer gray box pen testing, where I access the application from a black box perspective or from a gray box perspective with accounts, and then I try to determine if it's vulnerable. Now, once I find a vulnerability, it is helpful to be able to do a search in the code just to see the vulnerable function, because sometimes instead of doing the guesswork of seeing, maybe it uses this logic or maybe it uses that logic, all you have to do is literally just search for the function in the code and then just read the code, and then you have an exact understanding of the logic behind the application, which makes it easier to exploit it. So when it comes to CORS vulnerabilities, the first thing you need to do is identify the framework or the technology that is being used by the application, because that will largely indicate how CORS rules are usually set for that technology. So we talked about the Spring framework where you use annotations, whereas in other frameworks it might be a little bit different. So just Google the technologies that are being in use and how to set CORS rules for those technologies, and that's a step over here. And then review the code in order to identify if there are any misconfigurations in the CORS rules. So literally what I would do is look for strings in the code that matches how CORS gets set in that specific framework. And then when I find it, I review the logic behind the application that is responsible for determining if an origin is trusted or not. And if the logic is broken, I would attempt a proof of concept in order to see if it's truly vulnerable. Just like I mentioned in this scenario over here, you don't have the guesswork that is involved with black box or gray box pen testing, because you have the code that is responsible for the logic behind that specific function. And so all you need to do is review it. And once you've reviewed it and determined that it's vulnerable, all you need to do is develop a proof of concept. And that's pretty much how I would approach it from a white box pen testing perspective. Alright, so far we've learned the theory behind CORS vulnerabilities and how to find these types of vulnerabilities from both a black box and a white box perspective. The next thing we're going to discuss in this section is how to exploit CORS vulnerabilities. The way to exploit a CORS vulnerability largely depends on the application's configuration. We talked about two headers that are involved with setting CORS rules. The first one was the access control allow origin header, which defines the origins that are allowed to access your resources. And the second one was the access control allow credentials header, which allows the passing of credentials with the request. Now, the exploitation process is different if you have one versus both of these headers set. So the first exploitation proof of concept we're going to show is when both headers are set. So that's a scenario where the access control allow origin header is being insecurely dynamically generated and the access control allow credentials header is set to true. So if you come across that scenario, the proof of concept script would look something like this. This is a sample script from one of the lab exercises that we'll be covering in the next few videos. We'll explain it at a high level over here, and then in the dedicated video, we'll explain it in details. So this script is pretty much an HTML document that contains some JavaScript. The document appears to the victim user as just having the hello world message, so that's all the user sees. However, in the background, it uses XML HTTP request in order to perform a GET request, requesting the account's details page of the vulnerable website. It also uses the with credentials property and sets it to true to tell the browser to send the user's credentials with the request. Next, we send the request, and once the request is submitted and the response is received, we fetch the response and log it in our web server. So in order for us to deliver this script to the victim user, we need to host it on a web server. And the way we do that in the lab is we set up a simple Python server, and then we host the script on this Python server. Now, when we fetch a response, what this line over here is saying is add this string to my web server log, and then add the response text to it. And this function really over here is how we prove impact of exploiting the CORS vulnerability by extracting the response of the request, which shows us the account details page of the user that we're targeting. So if you come across another application which is vulnerable to a similar configuration of CORS, then your script would look something like this. The only difference would be the function that is used in order to prove impact. For you, you might want to extract only a portion of the text, or maybe you want to chain it to another vulnerability in order to prove maximum impact. So that this portion over here would be really up to you. The rest of the script would be very similar to what you would have in a proof of concept script. All right, so we talked about how to write a proof of concept script when both headers are set, and we specifically targeted a vulnerability in the way the access control allow origin header is being dynamically generated. Now, we also talked about the scenario where you whitelist the null origin, let's say for testing purposes. And I mentioned that this is equivalent to the wildcard character, or even worse than the wildcard character, because it also allows you to pass credentials with the request. And the way to exploit that would be very similar to the script that we looked at. So you could see over here, we're also making a request to the account details page of the vulnerable site. We're also passing credentials with the request. We're sending the request. And then when the request is done, we're logging the response of the request to our attacker server, which is running on port 4444. Now, the only difference is that we're running this script in an iframe sandbox. And the reason we do that is because when the request is made, it makes it appear as if it's coming from the null origin versus coming from the attacker server origin. And that's why I said that the null header is either equivalent to the wildcard character or even worse, because anyone on the internet who wants to exploit the misconfiguration that is in your site can just use this line of code over here in order to make their script appear as if it's coming from the null origin. Alright, so we discussed the use case where both headers are set. Now let's discuss the use case where only one of the headers is set, which is the access control allow origin header. Now, if you have a relaxed policy on the access control allow origin header, like using, let's say, the wildcard character, that doesn't necessarily mean that it's actually a vulnerability. Because without the access control allow credentials header being set to true, you can't access any authenticated pages. You can only access public pages. And if you're only accessing public pages, you could just request them on your own browser. You don't have to get the user's browser to make that request for you. However, there's a really famous use case that showcases that if you allow access from arbitrary origins, it could still mean that you're vulnerable. And this involves working from an internal network. So the developer over here is working from his organization's internal network, which is behind a firewall. The developer makes use of the IntelliJ IDE in order to program, and also uses the browser in order to access sites such as google.com or other sites like the catpics.com site, which is malicious and the user has no idea it's malicious. Now, the vulnerability, which was discovered in 2016, and this is a real vulnerability, was in the IntelliJ IDE. The IDE binds a server on localhost, which by definition of localhost is accessible only from the developer's laptop. But someone discovered that the access control allow origin header on that web server allows any origin on the internet to access this site. However, as an external server, I can't access this IntelliJ web server because it's on an internal network. So the way to exploit this misconfiguration is to get the user to visit a malicious site. And when the user visits the malicious site, the site requests the browser to request the SSH credentials from the IntelliJ server. And because the IntelliJ server allows any site on the internet to access its resources, it responds back with the SSH credentials to the browser, and then it sends it to the malicious script or the malicious web server. And the security researcher was able to chain this vulnerability with other vulnerabilities in order to gain remote code execution, and was awarded $50,000 for his finding. This is the article that explains it in detail. I definitely recommend giving it a read. Alright, so we discussed how to exploit CORS vulnerabilities manually. We can't end this section without talking about automated exploitation tools, which are web application vulnerability scanners. So for those of you that have never heard of web application vulnerability scanners, they're essentially automated tools that crawl your web application and look for vulnerabilities. Now, any decent scanner should have the ability to scan for CORS security misconfiguration. So if you're not currently using a scanner, you should definitely add it to your toolbox or to your methodology. I personally use Burp Pro Scanner, but there's so many other options out there, ranging from free and open source ones to very expensive ones. So it really depends on your organization and your preference. Alright, so we explained the theory behind CORS vulnerabilities, how to find them, and how to exploit them. Now let's talk about how to prevent CORS vulnerabilities. As mentioned earlier, CORS vulnerabilities are essentially misconfigurations, so you really need to ensure that you have proper configuration of cross-origin requests, which is only allowing trusted sites. And that could be by using a whitelist of the domains that you trust. So if you trust domain so-and-so, that gets included in the site. And then when you obtain a request accessing to read your resources, you extract the origin, you compare it with the one that is in the whitelist. And then if it exists in the whitelist, you allow the request to go through. If it doesn't exist in the whitelist, then you don't allow the request to go through. Next, you need to avoid whitelisting the null origin, and we talked about that quite extensively in this video. The reason we don't whitelist the null origin is because if you tweak your script a little bit, you can make any request appear to have come from the null origin, and therefore it's almost as equivalent as the wildcard character. Next, you need to avoid wildcards in your internal network, and we saw an example of that in the IntelliJ server, which allowed the user to gain SSH credentials to the server and eventually gain remote code execution by chaining this vulnerability with other vulnerabilities that he found in the application. Alright, this concludes our video. The following are the resources that were used to build this presentation. In the next upcoming videos, we'll gain some hands-on experience exploiting CORS vulnerabilities.